Now let's see what traditional machine learning actually do when it comes to building a model and giving an output, right? So in traditional machine learning, we usually do one-to-one, right? What I mean by one-to-one is that in traditional machine learning, you have certain kind of data points, and then you feed it to some sort of algorithm, and then you get an output. Okay, that's what we do, isn't it? That's what we do in traditional machine learning. You have your data points, you feed it to algorithm, and then you get an output. But what about the things that came before that data points? Okay, the n-1, the n-2, the n-3, the n-4, right? Maybe you have this year's data. What about last year's data? What about last 2 years, last 3 years, last 4 years data, right? Or maybe you're trying to predict some sort of, test, okay, some sort of a test. So what about the test that came in the previous sentence, in the previous 2 sentences, in the previous 3 sentences, in the previous 4 sentences, right? In traditional machine learning, we don't take into account the previous data, or the previous instances, or the previous states, okay, state of the data. We don't take into account that case. So that becomes a problem. If you take, for instance, the need for parse data. So if you take this part of speech over here, okay, and then I say that it is a quick read, okay, it is a quick read, and then I say I like to read. Now, if you take these 2 statements, right, where one is a quick read, and then this one's I like to read. Now, this one here becomes a noun, okay, this one becomes a noun, but this one becomes a verb, but it's just the same word, read. Okay, this is read and this is read. So if you don't take into consideration what comes after that particular word, you're gonna make a mistake. Okay, if we don't take into account these ones, we're gonna make a mistake of this. If we don't take into account of this one, we're gonna make a mistake of this one. Okay, so that is basically what happens. All right. Now, it also happens in say translation. Okay, you want to translate from one language to another. Okay, if you are translating say English sentence like I am going, right, to Hindi, right? Hindi is an Indian language, okay, one of the popular Indian languages, right? So if I'm translating this English sentence to Hindi, okay, then if I don't take into consideration the context over here, right, and I just do the translation word by word, right, what is going to happen is that this I is going to translate to say mer, am becomes hu, and then going becomes jaraha. Okay, so me hu jaraha, right, me hu jaraha. But ideally that's not how it's supposed to be. Okay, if we translate it to Hindi, it's not supposed to be like that. This is the ideal one. Okay, this is the ideal one. So the I is supposed to come here, which is the mer, right, but the hu is supposed to be here. Okay, and then the going, which is jaraha, supposed to be here. So me jaraha hu. Okay, the correct translation is me jaraha hu. Okay, and this is actually happens. I mean, if you go to Google and then you do use Google Translate and you translate certain words, right? If you don't take care and the words are translated word by word, it's going to mislead you and give you wrong translations, like something like this. Okay, so it has to take into consideration the context. Okay, the context is actually important over here, right? So that's why we say that there's a need for parse data or context. All right. Now, what traditional ML will try to do, right? Remember that I have changed whatever is here, right? So what traditional ML will try to do in order to do this is to define a fixed window. Okay, define a fixed window. So maybe if this is the current data, right, we will consider maybe 2 words that comes after that, or maybe 3 words that comes after that, something like that. Okay, so if we define a certain window that, okay, remember we talked about n gram, okay, n gram. So if you want to just use those kind of concept over here, right, maybe we will consider maybe the past 3 data points over there. Okay, and then when we do that, we will come up with an output over here. Okay, and then we will use that output, we use some sort of a sliding window, we slide it to the next function over here, and then that is also going to consider the next 3 data points over there, and then after that we slide it to the next function, and that is going to also consider the next 3 data points to the current one, and then we'll have our output. Okay, so the end result is going to be something like this, where you have the function where it considers the current data and then maybe other 2 data points that comes before that. So if we choose n gram, okay, something like that, which is going to take care of, or take into consideration the current data and also other 2 data points to make it 3 over there, which will feed it to the algorithm, right, to get an output, right? Something like that. Okay, this is okay, but what about when we're talking about distance passed? Okay, so what about maybe the first paragraph, right, or the first 2 paragraphs, or the first 3 paragraphs, or maybe the last paragraph, or maybe last year data, last 5 years data, last 10 years data, right? In that case, this one won't be sufficient. Okay, this kind of strategy will not be sufficient. All right, if you want to do sentiment analysis, for instance, all right, we can say that, okay, what the person said before the last word, right, is going to be very important, right? So if someone is writing a tweet on Twitter, right, and then the person wrote something like this: this movie was very bad. This movie was very bad, though I enjoyed the last scene, right? Though I enjoyed the last scene. Okay, something like that. So if you see this one, if let's say that you don't know what came after this, okay, then I enjoyed the last scene. If I tell you to predict the sentiment in this, you will say that it's a positive thing. Okay, the person is giving a positive review to the movie. Meanwhile, the person is actually giving a negative review. If you take the entire sentence, it's a negative review. Okay, it's a negative review to the movie, right? But if you don't take care of what came after that, you'll be thinking that it's a positive thing. Meanwhile, it's a negative thing, right? So that's what happens when you do something like sentiment analysis. Okay, or you do something like sentiment analysis. If you don't take care of distance passed, right, you'll be making a mistake. Okay, you'll be making a mistake. So now the solution here is introducing what is called memory. Okay, introducing what is called memory, which in a fancy way we call it a recurrence or state. Okay, so the previous state of the sentence, or the previous state of your data, or the previous state of your corpus needs to be taken into consideration. All right, and that's what you're going to do moving on, right? That's what you're going to do moving on, right? Talking about memory or recurrence, right? And then we see how we link that one to neural network. All right.